Okay, this video is on probability. The word probability just means the chance of something happening or how likely it is to happen. So you can use words, you can put it on a scale, or you can use fractions or decimals or percentages. So this first question, I just want to look at these different words. So if something is definitely not going to happen, you would say that it's impossible. If it is definitely going to happen, you would say that it's certain. And evens are for those events that are exactly in the middle, but they have to be half a chance of happening, half a chance of not happening. So questions like, your bus will break down on the way to school tomorrow. Don't just think because, oh, it can either break down or it won't, so that's a 50-50 chance. It's not a 50-50 chance unless your bus breaks down half of the time, which means that it would break down on a Monday and then not on a Tuesday, and then break down on a Wednesday and not on a Thursday. And that just doesn't happen. So just because there's two options doesn't mean that the probability is evens. The two options both have to have a fair chance of happening. So that would be things like you getting a heads or tails on an even or on a fair coin, or a baby being born, a boy or a girl. So only events like that where the two options have the same chance of happening, those are the only times that you use the word evens. So this first question, use a suitable word from the list to complete each sentence. Rolling a 7 on a fair ordinary dice. So on a dice the numbers only go from 1 to 6. So you getting a 7 isn't going to happen. So you would use the word impossible then. So they don't want you to be silly here and think, oh, but on a dice it might be a fancy dice with the number 7 on it or something like that. They've said a fair ordinary normal dice. A 7 ain't going to happen. Then rolling a 6 on a fair ordinary dice. For you to get a 6, there is only one of them out of 6 different numbers. So that would be unlikely that you're going to get it. It would actually be unlikely for all of the numbers on the dice, because each of them would have a chance of 1 out of 6 of coming up. So yes, you have to get something, but they're all just 1 out of 6, so each of them would be unlikely. If it had asked you something there like the chance of you getting an odd number on a dice, that would be a chance of you getting a 1, a 3 or a 5. So that would be 3 numbers out of 6. So for that you could say evens. Number 2 then, a fair spinner has 8 equal sections. Put arrows on the scale to show the probability of landing on each letter and label each arrow with the correct letter. So the chance of you getting an A, there's 1, 2 A's, so that's 2 out of 8. A lot of the time here they're very nice and they've split the scale up nicely for you. So it's already split up into 1 out of 8, 2 out of 8, 3 out of 8, then that's 4 out of 8 or half, 5 out of 8, 6 out of 8, 7 out of 8, and then 1 would be 8 out of 8. So an A, there's 2 chances of you getting an A out of 8. So that would be an A in there. A B, there's 1, 2, 3, 4, 5 chances of you getting a B. So go up to 5 out of 8 and put a B there. And then C only comes up once. So the chance of you getting that C would be just 1 out of 8. So this scale, your probability scale, goes from 0 for impossible up to 1 for certain. So if you were using percentages, that would be 100% there at the end. So your probabilities always either have to total up to 1 or 100%. Or something like 8 out of 8 if it's a fraction. Or 10 out of 10 or 15 out of 15 or whatever if it's a fraction. Number 3. These cards are put into a hat. So it looks like, yep, just 15 cards, just numbered 1 to 15. One card is chosen at random. What is the probability of choosing the card with the number 7? So the number 7 just comes up once. So the chance of you choosing that one would be 1 out of 15 cards. Then part B says, what is the probability of choosing a card that has a digit 3 on it? So a digit 3 is different to a number 7. I'm mixed up in the highlighters here. So a number 7 would just be a 7 on its own, whereas the digit 3 means any of the cards that have a 3 on it. So that would be 3, or it could also be 13. So there's 2 chances of you getting a card with a digit 3 on it, because that one has a 3 and that one has a 3 on it. So they didn't even put that in bold there, so it would just be something that you just have to watch out for, something like that. I just thought that those 2 questions were very similar, so that's whenever I noticed the digit 3. So the chance of that happening is 2 out of 15, because it happens on 2 cards. Then what is the probability of choosing a card that does not have a digit 3 on it? So you could go along and count to see how many other cards there are, or if there's 2 that have a 3 on it, then out of 15, if you take off those 2 that have a digit 3 on it, that leaves you with 13. So that would be 13 out of 15. So the chance of you getting a 3 is 2 out of 15. So not getting a 3 would be the remainder that would bring you up to 15 out of 15. And that's all to do with the fact that probability has to total up to 1, or in this case, 15 out of 15. Question 4 then. In a game, players roll 2 ordinary fair 6-sided dice, and the numbers rolled are added to get the score. Complete the table of possible scores. So they've given you a bit of the table here, going from 1 to 6 down the side for one dice, and then 1 to 6 across the top for the other dice. So 1 to 6, 1 to 6. And then they've been added together, so the 1 and the 1 to get the 2, the 1 and the 2 to get the 3, and they want you just to fill this bit in. So the pattern is going 4, 5, 6, 7, 8, so that would be 9. 5, 6, 7, 8, 9, 10. So that 10's coming from the 4 being added to the 6. Then 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12. Then one of the questions, what is the most likely score? So what score comes up the most then? That will be the one going down the diagonal of the grid. So the number 7 comes up 1, 2, 3, 4, 5, 6 times, whereas the ones either side of that, 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. So the most likely score then would be the number 7. It comes up the most. To win a prize, a player must score 8. Work out the probability of winning a prize. So winning a prize, getting a score of 8. So 8 comes up 1, 2, 3, 4, 5 times. So the probability of winning it would be 5 out of, and because it's a 6 by 6 grid, there's 36 different options in there. So the chance of you getting an 8 would be 5 different options out of 36. So that would be your probability. You can just leave it as a fraction. If they ask you, sometimes they would add on to the question saying that they're going to roll the dice 30 times or something like that. How many times would you expect to get a score of 8? So all you would do with this fraction at the end is just times it by 30 if they played the game 30 times, or times it by 100 if they played it 100 times. One more thing about probability. Sometimes they use the word relative frequency. That's just the fancy name for probability whenever it's from an experiment. So relative frequency, it just means the frequency in relation to the total. So the frequency of a score of 8 is 5 out of a relative total of 36. So relative frequency just means probability. Sometimes they give you a graph to go with relative frequency as well. And the probability down the side is normally something like a decimal. So most of the time for those graphs you just multiply, because you're kind of going in reverse. They've plotted the probability and they want you to go back to get the frequency. So just watch out for questions like that.